Hello, welcome to the show. Zankai, thank you so much for being on.
Yeah, thank you. Yeah.
So I'm Phil, I'm a partner at Webisoft. We build custom software, some of it in oil and gas. We've started this podcast series to learn more about the industry and talk about cool innovations that are coming up. My guest today, Zankai Liu. Do you want to take a couple minutes to explain your current position, who you are, and what you do?
Yeah, my name is Zhengkai Liu from Dioxide Materials. So I'm a CTO right now. Yeah, so Dioxide Materials, the operation uh, is based on our patent sustaining ion exchange membrane and associated catalysts and electrolyzers. Yeah, so that's my background on Dioxide Materials. Yeah.
So, as your position of CTO, what do you do most of the day?
Yeah, basically, yeah, day-to-day operation, technology development. Yeah, so we have a core products, an exchange membrane, electrodes, the materials, and electrolyzers. Yeah, an exchange membrane basically allow electrolyzer to run under alkaline condition. So that change the electrochemistry so we can uh, find other some reactions that are useful for renewable energy. Yeah.
How big is your team?
The company has 15 people. We have 5 people in R&D and 10 people in sales operation. Yeah.
Okay, so it's R&D and sales, very
Yes.
lean.
Yeah.
Would you consider yourself a hands-on CTO?
Yeah. So I joined the Dioxide Material in 2013 as an electrochemist and promoted to CTO a few years ago.
Okay. And so most of your time as CTO is spent managing other people or being, heads down in the code or in actual production work.
Basically, we have two field we need to work on. One is we have projects grants from DOE or other agency, so we need
Mm-hmm.
to work on projects. And the other thing we have an internal RD, so we keep improving membrane quality performance, right? So yeah, basically two roles. Yeah, we need to work on project based. There's specific milestone we need to meet at a certain time. And in RD, basically we need to solve the problem. If we have a complaint from customer, we need to solve those problems. Yeah,
I see. I see.
yeah.
How is the R&D landscape in the US? I'm not familiar with it too much. We're in Canada, and obviously we benefit from very generous R&D programs.
Mhm.
Do you have similar programs in the US for grants, or how does that
Yeah,
work?
yeah, yeah. We're located in US, right? So basically the RD project from DOE and NASA, sometimes from DOD. Yeah,
Hmm.
so basically we have two area we can work on. One is the CO2 utilization. So
Hmm.
basically we convert waste CO2 with renewable energy input, convert to some useful chemicals. One is the carbon monoxide, which is a very critical feedstock for for other industrial process. Yeah, and the other one we can split water into green hydrogen, also with renewable energy input. Yeah.
Can you tell me more about the type of products that your company has or services, if that's the case?
Yeah, so our business is basically the design, manufacturing, sell carbon dioxide and water electrolyzer and their components. So often we use renewable energy from solar and wind to drive the reaction. So that's basically our products. So do you want to deeper the product specific products or?
Yeah, sure.
We sell our cow ion exchange membrane and associated catalyst electrodes, and also we sell complete research grade cell from 5 to 250 cm square electrolyzer. Yeah, we are on the way to scale up our single electrolyzer to a commercial stack. Yeah, we are on the way to do that right now.
Meaning it's still in pre-production basically, or like when you say scale to commercial, what does that mean?
We sell research grade, basically small scale electrolyzer to customers. So membrane, anion exchange membrane, electrodes for water and CO2 electrolyzer.
Mm-hmm.
Yeah, that's our current sale, but we are on the way to commercial to industrial scale. For example, the megawatt electrolyzer stack. Yeah.
Okay, I see. Where do you think there is the most waste in your industry?
Waste?
Waste as in inefficiency,
Okay.
it could be waste of time, right? Waste of resource, waste of money.
Yeah, basically, there's some hiding cost. Electrochemistry, that's the component degrades over time. For example, membrane degradation, catalyst leaching out, degradation. So the initial performance may be very good, but the efficiency may drop off. And then also there's downtime. We need to service the electrolyzer stack and the replacement. So that cost is substantial. But this is not just the cost of new materials for the membrane electrodes, and it also includes labor cost for this construction, reconstruction, and potential loss of revenue from the idle facility. So this is basically the component degradation replacement cost. There's some other problem. We use CO2 as a feedstock, but that often captured from the industry resource. The impurity in the source CO2, even in trace amounts, that act as a poison to the catalyst and or the membrane, right? This necessitates pre-treatment and force the customer or the customer to invest in expensive large-scale gas scrubbing and purification equipment. So that's a substantial. The variable purity in the CO2 stock means we have a standard operation procedure that's probably overly conservative. We didn't consider those much impurity effects. So this will sacrificing peak efficiency to prevent degradation. So the true inefficient the capex we need to dedicate to purification process, right? So maybe we lose some further efficiency, so we need to optimize operating at a below optimal performance, so we can make sure that it's run long enough before replacement, right? That's another thing. And the third one, so if we scale up, there's some other cost, right? So early stage scaling often relies on highly skilled engineers to manage and troubleshoot every stack assembly and system startup. So this labor is significantly more expensive than optional technician, right? That's one thing. The true inefficiency is the lack of a fully automated, robotic, friendly manufacturing process. So relying on highly custom-made instruction so that introduce some variability and dramatically slow the rate at which we can achieve manufacturing economies at scale. So that will keep the capex high, especially at the initial stage, right?
Yeah.
Yeah. The other thing is just data acquisition and model discrepancy. So this often there's a often significant gap between laboratory or simulated data and real world application, especially if we use renewable energy, which is the intermittent energy that can stop and fluctuate at any time, right? So yeah, optional blind spots arise when the system thousands of sensors, that's the pressure sensor, temperature, flow rate, and current density, that maybe sometimes down. We don't get a complete set of data. So intermittent sensor failure or poor calibration can also make the root cause analysis not easy, right? Not straightforward. Yeah.
Do you think AI technology can help any of those points, especially on the automation side or maybe on the skilled worker side? Can AI
Yeah,
eventually
sure.
replace or enhance?
Sure, there's a machine learning, so we can optimize the process. Which sensor we need to have two sensor to make sure it works. Sometimes we need to redundancy, right? So
Mhm.
definitely that will work. And also machine learning can predict the solar energy output, so we can tell electrolyzer to run at the optimal
Yeah.
output, right? So that's a lot of things we can improve. Yeah.
What innovation are you most excited about that you're either working on, in your company or that you see coming in the industry as a whole?
For the innovation part, basically we have several parts we can work on. So first one, we need to operation at scale and reduce cost. Basically, the biggest opportunity is lowering the cost for the final product and achieving gigaton scale or megawatt scale, optimizing the manufacturing operation. Right. So first thing, if we transit from a batch process, normally we do in the lab, right, to high throughput continuous manufacturing for membrane production, membrane electrode assembly production. So we need to implement the robotics automation system in the stack assembly that will dramatically reduce labor costs and improve quality consistency,
Hmm.
right? Another thing, so we can work on is the component durability and lifetime. So innovation extending optional lifetime or AEM on the catalyst, that's very important. Every increase operational hours before replacement directly reduce the levelized cost of product. So this involves material science breakthrough to enhance chemical stability and mechanical resilience against degradation, like differential pressure, impurity, and fluctuating load. Another thing we can standardize and modularize the stack, right? So we can develop a highly standardized modular electrolyzer stack that can be easily mass produced and integrated into large-scale industrial plan. This reduces customer made, right? That the cost very high. Yeah. So this operation scale. Another thing we can talk about integrated system optimization. So we do power to X, right? We use electricity combined with the carbon dioxide and water to some useful chemicals, right? So this is the whole system. We need to integrate with the renewable energy to make a process economic viable, right? So a lot of things we need to work on, right? So first thing we need to develop a control system and optional protocol that allow the electrolyzer stack to efficiently, rapidly adjust their power draw in response to intermittent renewable energy source like wind and solar, right? So that's one part. Yeah. So another thing is the converting CO2 or even produce green hydrogen is an energy intensive process that generates waste heat. Yeah, we need to find out another new ways to utilize this heat, right? So, for example, we use a combined power heat management. So we can use this low energy heat to increase the overall system efficiency and lower the operating cost. Yeah. So finally, the last one, we produce carbon monoxide, for example, from with the CO2. There's the unreacted CO2. Sometimes we need to get away CO2, unreacted CO2 from the product. Yeah, so that will, if we can find a way to separate this unreacted cost or from the electrolyte with low energy separation technology, right, that will improve the economic analysis, right? Yeah. Mm-hmm. So there's another part we can do. So right now we have carbon monoxide and green hydrogen are the key products. Yeah, so we can also work on high value products. For example, if we can convert carbon dioxide to add some ethylene, formic acid, even sustainable aviation fuels, right? Use our technology. So this will probably have a premium price that offers that the high capital cost of the electrolyzer. Another thing we can integrate with the distributed CO2 capture system. So yeah, we have several CO2 source. We can use a refinery, so that's has a high purity CO2, but also often the flue gas have a low concentration of CO2 and often have some impurities, right? So if we can integrate our electrolyzer to low concentration CO2 source or even direct air capture system, so that will unlock our new markets beyond the large scale source, CO2 source. So basically, this is all we can think of right now. Yeah.
That's a lot already.
Yeah. Yeah.
What do you feel you're best in the world at?
Best word?
Yeah, what are you best at, basically? What are you better than your competition at?
Our foundation is just our patent sustaining AEM and exchange membrane that bring a wide application from CO2 utilization and green hydrogen production. That's our key and the core technology. So yeah, we are good at new materials development, right? So that's our key competency. Yeah.
Are you more worried about the speed of AI advancement or climate change?
Worry about climate change, but I'm not worried about AI. Global warming, the climate change, we need to work on some innovative way to reduce the carbon dioxide emission, or we can convert carbon dioxide into useful chemicals, for example, sustainable aviation fuels. So that will close the carbon loop, so we can achieve carbon neutral, right, economy. That's our goal, right?
Do you think that's a realistic goal?
Yeah, I guess. Yeah, because the weather become very hot in summer,
especially
cold,
where you are in Florida.
Yeah. There's some natural disaster, right? Like a hurricane season, right? In Florida, every year we have a hurricane season, right? That's basically climate change we cannot control right now.
Yeah, it's just more extremes, right? Even here in Canada, like obviously we have pretty mild weather, all things considered, but still it's either very cold or very hot now. Like very cold in the winter and then very, very, very warm in the summer, or more so than it's ever been. I feel in my lifetime. Yeah, we had a snowstorm a week ago, right? Where it's pretty rare that happens that early in the year, and so these occurrences are happening more and more. Do you think AI can help us solve climate change?
How to say, we can use machine learning to collect historic data and use a lot of weather condition we can predict what will come in the next few days or few months, right? We can predict to reduce damage to the residents, right? So that's one thing. Another thing, we can use AI and machine learning to predict intermittent energy output, so we can make use of that, right? Yeah, that's the main way to use renewable energy, not only from the grid electricity, right? So right now, with I think the more than 10 years, previously the solar energy just too expensive to use, right?
Yeah.
Right now, just 3 cents per kilowatt hour versus 30 cents per kilowatt hour from a grid. That's a big advantage, but it's intermittent. So we can rely on AI machine learning to make use of this, right? That will be wonderful, right? We can reduce reliance on fossil fuel, that reduce carbon dioxide emission, right? That's we have win-win, right?
Yeah, of course. What energy technology are you most excited about, like in the future? Which one do you think will become like a game changer?
If we can convert renewable energy like solar, wind, to some sustainable aviation fuel, we can reduce the reliance on fossil fuel, right?
You said aviation, like
yeah,
so
aviation
okay, yeah,
fuel.
yeah,
Because
because that's a
that's a
hard one,
big,
right? That's a
yeah,
hard one to solve. Yeah.
yeah. We know someone is working on electric airplane, right? Helicopter,
Yeah.
right?
But I hear that's too. That's really hard to pull because
Yeah.
it's just not enough power, right?
Yes.
Yeah.
Yeah.
If you had a magic wand and you could fix any inefficiency in your industry as a whole, or even within your company, right? What would it be?
Fix the inefficiency, right?
Like an inefficiency, something
Yeah.
that you find is not efficient, and it could be external to you guys, obviously outside of your own control, but you could fix it, right, with a magic spell. What would that be?
Yeah, I think keep the product consistent. So basically,
Okay.
quality control.
Quality control. Yeah, that's a big one.
We do see sometimes the inconsistency, right, in the product.
Yeah.
You don't know what happened, right?
Yeah,
If
yeah.
we have a way to monitor some unknown factors, right, we can solve that. That would be magic.
What is the biggest source of issues with quality control? Is it human, or is it just the environment, or?
Possibly the human, right? Sometimes, the technician, we have a SOP,
Yeah.
right? Everyone follow same SOP may get different results.
Is it because they're not followed properly, or is it they're too vague, or is this just more of a human problem, like a human error?
We still need to figure out. Yeah.
Listen, we have a bunch of SOPs on a drive somewhere, and I'm pretty sure half the team have not read them. So that's
SOP there, but he only read he want to read, right?
Yeah. Or you read it once and then you forget about them.
Yeah. So that will introduce, if we have a robotic to work on that part, right? So the quality control will be much easier.
Yeah.
Every human make mistakes. You know why, right?
That's human. Right. I mean, right? AI makes mistakes as well, but it's
more consistent, right?
Yeah, it's a little more consistent.
Yeah.
Final question for you. What are you most excited about for the future?
Yeah, if we can drive our technology to commercial scale, that would be really exciting. Right now, still development stage. Yeah, we work in lab, we collaborate with some industrial partner, but someday we will see this in operation at scale, right? Yeah, make convert CO2 emission to some aviation fuel. That would be wonderful.
Yeah, that sounds great.
Yeah, we have both technology convert carbon dioxide into carbon monoxide. We also have green hydrogen production. If we combine these two to make a syngas, syngas can be easily converted to aviation fuel. That's a Fischer-Tropsch process. That's well-known mature technology. Right?
Hmm.
I will see that in probably next few years. Yeah.
Oh, that's exciting actually. I hope that happens. Well, Zenkai, thank you so much for jumping on. This was great.
Okay, thank you. Yeah.